Yes, hey, lead code fam, welcome back. Let's solve 118 Pascal's triangle. Yeah, again, if you know what's Pascal's triangle, then you will understand the question, not necessarily come up with a solution on seeing the question first time. But hey, if you come up with the solution on seeing the question for the first time, then you might be a math prodigy, not math, but a computer science prodigy, computer science and DS prodigy. So yeah, let's go through it. You'll be given an integer num rows, and you have to return the first num rows of the Pascal triangle. Yeah, they have conveniently given us an example also. Yes, for the first question, yeah, for numbers is equal to 5, 1, 2, 3, 4, 5. Yeah, and see how it works. First you'll have 1, and then you'll have 1, 1, which is actually the sum of 1 with its left and right neighbors. And actually, since it has no left or right, it is 0. And then you have 1, which is the sum of 1, and then the middle number will be the sum of the above two numbers, and the end number will also be the sum of the above two numbers, but yeah, 1 and the next number, which is actually nothing, none. And it goes on like that, the pattern continues. And yeah, and if you thought on seeing this question, if you think you can solve it using recursion, then you're absolutely not completely wrong. But yeah, you can solve it using recursion. But there is an easier way to solve it using iteration also. But hey, okay, let me do one thing. I'll first show you the iterative solution, and then let's go through how to do it recursively also. And yes, uh, let's start with it. The constraints are one, at least one node will be present, so it is better to get that edge case off. So if num rows becomes equal to 1, then you can directly return 1. Yeah, or at least yeah, this is a classic stack problem. No, yeah, it is theoretically not a stack problem, but hey, yeah, what you do is actually use the top value, which yeah, it coincides with the definition of a stack. But yeah, you can call it also stack also. You have a stack, and stack will, yeah, initially it will have 1, which is the top node. And for, you have to go till where, till you have to iterate through num rows. You have to iterate num rows minus 1 times, because yeah, for n is equal to 1 you already checked. So for I, for yeah, you don't actually use the this variable, so you can directly call it as underscore for I, for underscore in uh, num rows minus 1. Yeah, so now just think about it. So how you will do, actually what you have to do is, to create this one, first you need to have a new array. So let me call it temp, and see how it works. So you take the value, yeah, you see this row, you take the above value, you take the sum of the above values, you take sum of the above values. So 0 plus 1, 1 plus 1, 2, and 1 plus 0. And again consider over here, yeah, let it finish. Yeah, 1, 1 plus 0, 1 plus 2, 1 plus 2, 1 plus 0. And over here also, this is 1 plus 0, this is 3 plus 1, and this is 3 plus 3, which is 6. And this is again 3 plus 1, which is 4, and this is again 1 plus 0, which is 1. So on seeing that animation, you should be able to come up with how to do it. So uh, for I in range, what, the top of the stack, because first you will have this value. Yeah, consider you have this row, then to do this row you actually need this. So yeah, this is like kind of dynamic programming approach, where you build upon the previous solution. For I in range, length of stack at the position minus 1. Yeah, you have to do plus 1 over here. I'll tell you why not over here. Yeah, you have to do it over here. And yeah, see over here, what you notice, all the left and the right extreme ends are ones. So yeah, take care of that. It's it in the beginning itself. So if I becomes equal to 0, or I becomes equal to length of the stack at the position minus 1. Yes, yeah, the what happens is, if you don't add this minus 1, then this condition will never reach true, and you will not at all get this 1, which will obviously lead to inconsistencies as you proceed. So that's why I'm using plus 1 over here, so that I get the I is equal to length of the top of the stack minus 1, mainly to, yeah, to get these values. So yeah, if this happens, then directly append value 1 to the stack. Or else what you will do, yeah, consider this 3 over here. It is I minus 1 and the value of I plus the value of I minus 1. Yeah, if you consider this, it is the value of I plus I minus 1. If you consider this, it is the value of I and the I minus 1th value. So temp dot append stack at the position minus 1 at the position I, and add stack at the position minus 1 at the position I minus 1. And yeah, This is like the complete algorithm. Then after this, just append the temporary array which you created to the top of the stack. Temp, and by now you should have your answer. Just let's just check it out once. Is there any error? And yeah, it's running. Just submit it once. And yeah, it works. And yeah, it's pretty obviously, it's like super efficient. So yeah, now as I told, let's go over the recursive way also, because hey, if it is possible to do it recursively, then why not try it out? So yeah, again, yeah, this is the guard. I don't even think you require. Okay, yeah, let's keep the guard clause and yeah, define a recursive function. And which will, what will it take? Yeah, just think about it. It will take your stack variable and the num rows. And yeah, by any chance, if num rows becomes a row ws, if it becomes equal to 1, yeah, then what you will do? Yeah, if it becomes equal to 0, then what you will do? You directly return the stack because that's your answer. Or else what you do, you again declare a temporary variable, and now you want the top of the stack. So yeah, rather than referring it as a stack at the position -1, let me do it's stack at the position -1. Yeah, and now you have to build on top of previous answers. So what you have to do, for I in range length of stack -1, which is I have declared it as err. So yeah, now the same thing, if I becomes equal to 0 or I becomes equal to the length of the array. Yeah, again, I hope you understood why I took +1 over here. Or I becomes equal to the length of the array. Then what you do? Temp dot append the value 1. Else temp dot append the value of arr at the position I plus arr at the position I -1. And after this, yeah, temp, yeah. Now you just think about it once. So what you have to do? You have to recursively, if number is not equal to 0, that means the solution is still left. So recursively call the same function again. So return the recursion of stack yeah, stack. And but what happened, you already built one row, so just num rows -1. Yeah, let me declare array is equal to recursion of stack and num rows. Let me print arr, because yeah, even I'm not that proficient in recursion, so it might be extra -1 over here, mainly because I checked for num rows. Yeah, it was actually num rows -1 because I have already checked for the first row. I think directly you can return this, return the recursive way of the solution. Let us just compile it once. Yeah, and it is obviously working. I don't think you need this also. Let's just remove that and check once. Case 1, is there any case of 1? Yeah, it's there. Yeah, there is no need for guard clause also, because at the after the first check itself the stack will become empty. Yeah, as soon as you do numbers -1, what will happen is numbers was 1, so numbers will become 0 directly over here. So we'll return the stack, and stack is already declared with the value 1, and that will directly be returned over here. So yeah, let's submit it. Bonus recursive way to do it also. Just know how to do it recursively also. It might not be essential, yeah. And obviously recursion, it is pretty slow, and you are getting very bad time complexity. Yeah, let me just submit it once again to see if I get a better run time. And yeah, it might not be that efficient, but hey, it works, and what works, right? Again, as I tell, know all the tools and be sure to use it whenever essential. And yeah, so thank you. Grind more DSA, you can do it. I believe in you.